Hello everybody and welcome to exercise 7 on page 67 of the workbook. And this is going to be a graphical exercise in seeing if you can interpret what kind of information a slope field is really giving you. And this question is asking us a lot of things, but I'd like to just focus on the part where we're taking these formulas, these differential equations, and seeing if we can match them to the slope fields. Okay, now notice that in this problem they're referring to the slope fields as being on page 69, so we have to page a little bit ahead, okay, to find the pictures, the slope fields. Now notice there are 8 pictures and 8 differential equations, and we're just trying to match them up. Okay, and what I'd like to do in this video is to just do 2 of the problems together, okay, just so you can kind of get the idea of what you might do to make your match. And I want to make the comment that the tips that I give you are just 2 possible ways that you could approach matching these formulas with their slope fields. There are a lot of other approaches that you could use, so I'd encourage you to be creative as you're working through this. All right, well, first of all, the key idea, what do we need to know to really get started on a problem like this? Okay, well, all of these differential equations involve derivatives. You see a bunch of y primes as you look at these formulas. What is it that y prime represents geometrically? The derivative represents slope, and that is the key, that every time that you see a y prime, it represents slope. If you can remember that, that's going to really help you to make these matches. Okay, so I'd like to start first with one of the easier formulas and sort of try to make a global match. Think about the formula big picture. Okay, so how about the very first one on our list here? Okay, the differential equation that says that y prime is equal to 1. Okay, what that's really saying, if we put it into words, is that we're looking for a slope field where the slope, that's the y prime on the left-hand side, is equal to 1 everywhere in the entire field. Okay, so to find a match for this formula, we're looking for a slope field where the slope everywhere in the field is the same and it's always positive 1. Okay, so with that in mind, let's look at our pictures and see if we can pick one out that kind of has that property. Okay, as we kind of do a tour through these, do you see a slope field among those 8 that fit that description? We get the same slope everywhere, and its number could be positive 1. Okay, one that kind of jumps out at me is F here. Okay, every slope is positive, and it's the same everywhere. So I think we found our match for formula 1, which is y prime equals 1. Okay, that's what I like to call a global strategy. We kind of looked at the differential equation, interpreted the slope overall, and came up with our match that way. Okay, let's look at one more together. Okay, one where it's maybe not so easy to guess it just by looking at the formula. So maybe jump down to the one right below that, formula 5. Okay, now this time that formula is too complicated for me to just look at it and see what the slope is going to be everywhere. Okay, so what I'm going to use for this one is what I like to call a test point strategy. Okay, we're going to just pick a couple of points. Okay, totally our choice where we pick them, and ask what is the slope at each of our test points. Okay, and I'm going to choose a point that's in each quadrant. Okay, so 1, 1, that would be in the first quadrant, minus 1, 1, that's over in the second quadrant, and so on. Okay, nothing special about these points except that I'm choosing a point in each quadrant. You could choose other points, that would be okay. And what we want to do for each of those points is to figure out what would the slope be. Okay, well remember, the slope is y prime, and our equation is telling us we get the slope by taking negative x times y. Okay, so to find the slope for the first point, 1, 1, we would just substitute 1 in for x and y, okay, because 1 and 1 are our x and y coordinates. So if we do that, plug 1 in for x and 1 in for y, what do we get? Negative 1 times 1 is negative 1. Okay, so at the point 1, 1, we should have a slope of negative 1 in our slope field. Okay, and we just do that for all of these points. So we move down to the point negative 1, 1. Now x is negative 1 and y is 1. So we're going to get negative 1 for x, 1 for y. And if we do the algebra this time, we're just going to get positive 1. Okay, and remember, slope for this differential equation is equal to negative xy. So that's the formula that we're using to calculate slope. Okay, moving on to negative 1 and negative 1. Okay, we're going to get negative x times y. This time we've got 3 negative signs. That's going to get us back to a negative. And then finally, if x is 1 and y is negative 1, we're going to get negative 1 times negative 1. That's back to a positive 1 again. Okay, so what does all of this mean? Well, it means that we're looking for a slope field where all 4 of these slopes match. So if you go to the point 1, 1, you should get a slope of negative 1. If you go to the point negative 1, 1, you should get a slope of 1, and so on down the line. Can we find a slope field where all 4 of those slopes match at the right points in our field? Okay, well, let's scroll here. Okay, and if you were doing this on your own, this would probably take you a little bit longer. You'd need to one by one kind of go through these fields. Maybe what I could show you is sometimes you can rule out slope fields. So for example, let's say that we wanted to ask, could slope field A match? Okay, well, we would go to the point 1, 1. Notice that we get a positive slope there. If you look back at the work we did on the previous page, we got a slope of negative 1 at the point 1, 1. So we know that A can't be a match, okay, for formula number 5. Okay, and you could visit some of these other fields and rule out some other possibilities as well. What would work in our case? Okay, well, I claim that slope field D is what we want. How would we convince ourselves of that? Well, we'd go to those 4 points one at a time and just check and see if it looks plausible that the slopes match. So 1, 1 would be here. And notice that we've got a line with a negative slope. We were supposed to get a slope of negative 1 at 1, 1, and so far so good. And then move over to the point negative 1, 1. Okay, that's about here. And what do you think? Does it look like a positive or a negative slope there? I'm seeing a slope that goes up. That's also consistent. We got a slope of 1 at the number negative 1, 1, and we just keep going. Okay, so maybe go over to negative 1, negative 1. That would be about down here. Notice that we're getting a negative slope. That's also consistent. We got a negative 1 for our slope at that point. And then finally at 1, negative 1, we're down here. You can see from the slope field that we get a positive slope there, and that matches the slope of 1 that we got at the point 1, negative 1. Okay, so we checked all 4 of our points and confirmed that slope field D is consistent. That's pretty good evidence that this should be a match. Okay, for formula 5. Okay, and like I say, as you do the rest of these, those are 2 possibilities of what you might do to make matches, and you may very well think of other strategies as you're going through these. All right, so see what you can do with the remaining parts of this problem.